Hello everyone. So I am Aditi. So I'm giving OS presentation, and the topic which I got is first come first serve CPU scheduling algorithm. So firstly, I'll give you the brief introduction, that is what is CPU scheduling. Okay. So CPU scheduling is of processes work is done to finish the work on time. CPU scheduling is a process that allows one process to use the CPU while another process is delayed. That is, which is made to wait, or that is made in a standby mode due to the unavailability of the resources, such as input output resources like our keyboard, monitor, printer, and all that. So processes are made to wait, and their chances, and depending upon the algorithm, the processes are given chance, so that they can be executed on time, thus making the full use of the CPU. The purpose of the CPU scheduling is to make the system more efficient, faster, and fairer. That is the motive of this various algorithm, is that is the system should be more efficient, faster, and fairer. Nextly, whenever the CPU becomes idle, the operating system must select one of the processes in the line ready for launch. That is, whenever the operating system is idle, that is, it does not have any process to execute. So, depending upon the algorithms such as FCFS, round robin, then shortest job first, in which we have preemptive and non-preemptive. So, by executing these algorithms, the process is given to the CPU for the execution. The selection process is done by CPU scheduler. That is, the CPU scheduler selects between the memory processes ready to launch and assign the CPU to one of the processes in the queue. So this was the introduction about CPU scheduling. We'll look more further or more deep for FCFS, which is first come first serve algorithm. Okay, now as I already given you the introduction, let's dive deep. So now we have several criteria that can be used to compare the performance of CPU scheduling. Okay, so first is CPU utilization, that is keep the CPU as busy as possible. Next is throughput of processes that complete their execution per time unit. Then we have turnaround time, amount of time to execute a particular process. Waiting time, amount of time a process has been waiting in the ready queue and it's waiting, literally waiting for its chance to come. Response time, amount of time it takes from when a request was submitted until the first response is produced, nor the complete output. Meeting the deadlines, that is real time systems. Okay, now this was about the CPU scheduling criteria. Okay, now optimization criteria, that is maximize the CPU utilization, maximize the throughput, minimize turnaround time, minimize waiting time, minimize response time, and minimize variance. Okay, so there are just two things which we have to maximize, that is CPU utilization and throughput. In the examples, we'll assume average waiting time is the performance measure. Okay, so like we'll be taking average waiting time for the measurement of the performance of the algorithm. Only one CPU burst in milliseconds per process. Now here comes the first come first serve FCFS scheduling. Single FIFO ready queue, so it has just one, that is first in first out ready queue. It is non-preemptive. That is, what does it mean? That process is not interrupted in between. The process is made to complete fully, or it's executed fully without any disturbance in them. Then it is simple to implement and understand. Average waiting time dependent on the order processes enter the system. Okay, now let's study the first come first serve scheduling algorithm. Here we have three processes, P1, P2, P3. The burst time is for P1 it is 24, P2 it is 3, P3 is also 3. Okay, so now what is burst time? Burst time is the execution time, like how much time it takes to get executed. And the criteria for FCFS is arrival time. And as I already mentioned, that its mode is non-preemptive, that we will let the process completes its execution fully. Nextly, as you can see the chart, we have Gantt chart. Okay, so as we know that the criteria for this is arrival time. Okay, so suppose that the processes arrive in the time P1, P2, P3. Okay, so the Gantt chart for this will be P1 will get executed first. the reason behind is that the burst time, or not the burst time, the arrival time is less as compared to uh, f2 sorry p2 and p3. So this is the FCFS algorithm, that whichever process comes first, it will get executed, and then p2 and p3. Okay, so in the same way, p1 will take 24, uh, as we have considered milliseconds, so 24 milliseconds to get executed. Then the arrival time of p2, uh, p2, okay, so then p2 will get executed, and then p3 will execute it. So this is getting executed in the sequence they have arrived in the system. Now let's calculate the waiting time. The waiting time for p1 is 0 second, cause it was the first process that came into the queue, so it is executed first. Next, the waiting time for p2 is 24, because because it arrived after p1. And then we have p3, whose waiting time is 27, because it arrived after p1 and p2. Then average waiting time. So what we will do, we will add up the waiting times of processes p1, p2 and p3, and we'll divide it by 3. So we'll get the average waiting time, which is 70. So this was the first come first serve scheduling algorithm. Okay, now here is another example. Suppose the processes arrive in the order p2, p3, p1. That is, the p2 have arrived first, then p3, and then p1. So the Gantt chart will change as follow. So we will have so that the p2 will get executed first. Reason behind is that it came first in the system. So according to FCFS scheduling algorithm, it will get executed first, and then as p3 arrived after p2, so p3 will get executed, and then p1 will get executed. So the waiting time for p1 is 6, for p2 is 0, because it arrived first. Then we have p3, who had to wait for 3 milliseconds, and here the average waiting time is 3 milliseconds. Okay, so now the problem, so this was the working of FCFS algorithm. The simple statement for this is that whichever process will come first, it will get executed first. Okay, now let's study some advantages and disadvantages. So firstly, it is very simple and easy to understand. FCFS provides fairness by treating all the processes equally and giving them equal opportunity to run. Okay, but the here the problem, that is disadvantages, is that convoy effect, that is shortest processes behind long processes, and it is non-preemptive, that is not suitable for time sharing systems. Then the process with less execution time suffers, that is the waiting time is often quite long for these processes. Favor CPU bound process than input output bound process. So this was an idea about FCFS algorithm. Thank you.